Hello, today we're going to review how to compute residuals. So let's take a look at our problem. It says the table and scatter plot show the time spent studying, X, and the midterm score, Y, for each of 11 students. The equation of the line of best fit is Y equals 3.8X plus 15.12. Now here's our graph with all of our points plotted, but notice over here we have this table. This table represents the points on this graph. So these are our exact values. Okay, so let's take a look and see what we're going to do today. It says use the equation of the line of best fit to fill in the blanks below. Give exact answers, not rounded approximations. So first thing we need to do is we need to figure out what our observed midterm scores are. So what we want to do is go, okay, at 11.9 hours, what was the observed midterm score? Now, a lot of people want to go to the graph and go, oh, let me go see what that is. But that's going to be really hard to determine. And we're lucky because we have all of our data right here in our table. So really, we don't even need the graph. Okay, we just don't even need the graph when doing these problems. So we come over here and we go down to 11.9 hours. And we notice that for the students that spend 11.9 hours studying, their midterm score was a 70.00. Now remember they said they want you to be exact. So we're going to put 70.00. Now we can also go ahead and look for our observed value for 18 hours. For those that studied 18 hours, our midterm score was a 75.00. So now we have our observed values. But now we need to figure out where do these predicted values come from. Well, predicted means we're going to use the equation for the line of best fit. Okay, so I'm going to make a little note here. Use So for these ones, we're going to use our line of best fit equation. So here's what we're going to do. Our time in hours is our X. Okay, and we show that in two places here. That's our X. So we're going to take our equation for our line of best fit, and wherever we see X, we're going to plug in 11.9. So notice we have our equation up here. And so now I'm going to put this in my calculator, and I'm going to figure out what Y would equal when X is 11.9. So can I come up here and get my calculator? I'm going to go 3.8 times 11.9. And then I'm going to add to that 15.12. So we get an answer of 60.34. So according to our equation for our line of best fit, those students that studied 11.9 hours would make roughly a 60.34. So I'm going to put that right here in my predicted value. Now I'm going to do the same exact thing. This time I'm going to use 18 for our time. So same formula, same line of best fit, but this time our X is going to be 18. So get my calculator back up here, clear it out, 3.8 times 18. And then we're going to add to that 15.12. And we get a value of 83.52. So that is our predicted value, 83.52, for those students that studied 18 hours. Now, to compute the residual, we just simply take the observed minus the predicted. All I'm going to do is come down here and go, okay, I'm going to take 70 minus 64, and that's going to equal my residual. And I'm going to do 75 minus 83.52 to get my residual. I get 9.66. And for this one, I get negative 8.52. And it's okay for it to be negative, okay? So you want to be exact. Okay. All right, so now we have our two residual values here. So just to review, observed values come from the table, come from the data. Predicted values come from us taking these values for X, substituting them into our equation for our line of best fit, and solving for Y. Those are our residuals. And then to compute the residual, we just simply subtract the observed value minus the predicted value. I hope you found this video helpful. If you have any additional questions, please reach out to your instructor. Have a great day.